first step is you want to take notes because you'll need these to refer to when you are doing your calculations. I would use the centimeter side because we're going to start using metric. I would make a line 10 centimeters, marking off each centimeter. Long. Okay. I'm going to label these. This is height in meters. 10, 20, 30. Length, also in meters. 10, 20, 8. And I'll come down here. I'll go back up. I'll go down for a loop the loop. Maybe kind of spin around and come down over here. If you end at the bottom, I'll maybe draw my little cart, you guys. The next step will be to label a bunch of points between A and H. You need 8 total points. So B, this C. So the next step is to figure out our total potential energy at point A. Our mass, which is going to be equal to 2 times the average weight of a rider. And then you're going to add the weight of the car. A quick Google search tells us it weighs 535 kilograms, 655 kilograms. So the mass times the height, so this is the mass, times the height of 100 meters above the lowest point, 100 meters, times acceleration due to gravity. That's going to be 9.8 meters per second to the -2, which is another way of writing meters per second per second. Mass times height times the acceleration due to gravity is potential energy. Now we're talking about point A right here. So the potential energy at point A equals the mass times acceleration due to gravity times height. We've got height, we've got mass, we've got acceleration due to gravity. This one, acceleration due to gravity, will always be this number. This one, the height, will change as the height of the roller coaster car changes. This mass won't change once you figure out what it is, unless you are losing riders, which is a no-no. 655 kilograms times 9.8 meters per second squared times 100 meters. That will equal 641,900 kilogram meters squared, because meters times meters, times seconds to the -2. The kinetic energy up top, since it's not moving, it's going to be 0. The total energy, therefore, is this plus this, which is 641,900 kilogram meters per second squared. As we remember from the simulator, the total is the potential energy plus the kinetic energy. You're going to go through this process, starting by finding the potential energy. The total energy is going to be the same at every point. Then you're going to subtract potential energy, and that'll leave you kinetic energy.